finding x and y intercepts. So in our last set of videos, we figured out how to graph equations by plotting points. We randomly picked x values, or sometimes we strategically picked x values, and then we figured out the y values that go along with it. Now, we know on the graph what x and y intercepts look like. So let's reference these graphs that we drew in the last video. If we wanted to pick out our x-intercepts, those are the points that intercept our x-axis. So in this video, our x-intercept is the ordered pair 3, 0. If we want to pick out our y-intercepts, those are the points that intercept our y-axis. So in this graph, our ordered pair of our y-intercept is 0, 2. Now, those we just randomly found by picking points. We also had another graph that we looked at here. Again, we have some x and y intercepts. Let's start with the y-intercept. We see it here. That came from the ordered pair 0, negative 1. And we also have x-intercepts. There's 2 of them, but we actually only plotted 1 point. 1 here is the one that we plotted, and that's at 1, 0. But there's actually a second x-intercept here that we did not find. In this video, we want to figure out how do we find those x and those y-intercepts. Starting with the x-intercepts. I have on my graph here, I have lots of blue dots there, and these are all x-intercepts. I'd like you to pause the video and write down the ordered pairs of all of those blue dots and see if you notice anything about them, what they have in common. What you should have noticed is that the y value that goes with all of those points is 0. So this ordered pair here is 4, 0. This ordered pair here is negative 8, 0. Our middle ordered pair, the origin one, is 0, 0. So all of those coordinates have our y value of 0 in common. So to find the x-intercept, we are going to let that y value be 0, and then we are going to solve and figure out where our x-coordinate is going to be. Now let's see what about the y-intercept. So again, have lots of blue dots there that are y-intercepts. Pause the video and write down the ordered pairs for all of those y-intercepts and see what they have in common. Hopefully you notice that all of the x values are 0. So if I start with my origin, of course the x value is 0 there. This ordered pair down here is 0, negative 8. This ordered pair up here is 0, 6. And all the rest of them are going to have 0 as the x-coordinate. So to figure out what our y-coordinates are, we let the x-coordinate be 0, and we solve for our y value. Example 1. X squared is equal to negative y plus 1. In this example, we want to find our x and our y-intercept. So let's start by finding the x-intercept. And we just learned that we find the x-intercept by letting our y value be 0. So I have x squared is equal to negative. Instead of my y value, I substitute in 0 plus 1. Gives me x squared is equal to 1. Solving this equation by getting rid of my square means I need to force in a square root, which also means you need to force in a plus or minus. So that gives us a solution of x equals positive and negative. The square root of 1 simplifies as 1. But these are x-intercepts, meaning these are points on the graph, so our final answer should be in point form. So we have two of them. One of them is at 1, 0, and the second one of them is at negative 1, 0. So our x-intercept should always be in the answer of your x value and then 0 for your y value. Let's go ahead and figure out what our y-intercept is. Again, if we look back, we find our y-intercept by letting our x value be 0. So, in my equation, I'm going to let my x value be 0. That gives me 0 squared is equal to negative y plus 1, which gives me 0 is equal to negative y plus 1. If I want to isolate my y variable, what I'm going to do is I'm going to move it to the left by adding y on both sides. That gives me y is equal to positive 1. Again, this is an intercept, so I should write it in intercept form. Okay. I plugged in 0 for x, and I got out 1 for my y-intercept. So your y-intercept is always going to be in the form of 0 and whatever number you get for y. So in this problem, we had 2 x-intercepts and we had 1 y-intercept. X-intercepts, you can have as many as the problem demands for, and I will explain that at a later time. In this problem, it demanded for 2 of them, so we should have 2 x-intercepts. Example 2. Negative 2x plus 4y is equal to 12. I'd like you to pause the video and see if you can come up with the x and the y-intercepts for this problem. I'm going to start with my x-intercept, or intercept, depending on whatever the problem asks for. And we do that by letting your y value be 0. So in this equation, I have negative 2x plus 4 times y is equal to 12. And again, my y value is 0. Well, 4 times 0 cancels out, so I don't really have to worry about that. So it gives me negative 2x is equal to 12. And then to get x completely isolated, I divide by negative 2. Gives me x is equal to negative 6. Don't forget to put your answer in ordered pair form. So my x-intercept is negative 6 for my x value and 0 for my y value. So this problem only mandated that I needed 1 x-intercept. My y-intercept. I find it by letting my x value be 0. So I have negative 2 times 0 plus 4 times my y value is equal to 12. Negative 2 times 0 cancels out. So just have the equation 4y is equal to 12. To solve for this, I just need to divide both sides by 4. And that gives me the answer y is equal to 3. Again, don't forget to put it in intercept form, where you substituted 0 in for your x-coordinate and 3 in for your y-coordinate. So that is your solution for your y-intercept.